Hi, how you doing? Thanks for tuning in to my YouTube channel or visiting my website. So I'm gonna go over my little diagram here and go into some of my K3 Kubernetes setup. So first off, kind of explain the environment to you. So best way to look at this is this whole part up here, everything in the yellow box there, that's all running on one little physical box. So everything here is self-contained, including the networking and everything else. All the K3 instances and their storage is all using NFS shares, so it's all going across the same thing. So that's kind of cool. But I'll get into that in a little depth later. Down here, I've got a Cisco switch. So I set up a trunking on my switch and linked that to the NIC team that is on the physical device. And go over the physical device just a little bit here. So let me see if I can bring that up. So I got it. So this is what I got. I got like a little 7-inch touchscreen up here. Got this for like $50 off of Amazon. It's awesome, and it runs off of USB power. But anyways, this is a B-Link device. It's got a AMD Ryzen 7 in it, and well, here, let me show you the specs. So it's an AMD Ryzen 7. It's got 8 cores, 16 threads, 16 gigs RAM, shared video, 500 gig drive. So, oh, and you can see all the ports in the back and everything here. And it's got a USB-C in the front and a standard USB in the front as well. So, as you can see right there, that's my backup hard drive. It's got a little USB-C too. So yeah, this thing's a beast. I've been throwing everything at it, as you can tell by this. I've been throwing everything at it, and it's just rocking and rolling. So it's running this and handling this with no problem. So let me get into what the diagram really is and why we're here. So I want to kind of go over my K3 setup. So started at the end user. End user comes in through the trunk. Yet again, the trunk and the NIC team's optional. You don't have to do that. So that's where the end user comes in to my physical host. Then you have to set up a bridge for your KVMs, or your VMs will not be able to talk to your local host, the hypervisor across the network. Found that out the hard way. So I want to point out one thing is this up here, my NFS server. Let me on my NFS server and the shares that are feeding into my volumes, persistent volumes on my pods. All of that is running within the VM. Sorry, this is running on the physical server, but the way this connects is across this bridge. So the bridge is kernel based, my KVM is kernel based. So when my VMs come out to talk to my NFS server, they go out through the KVM, out my bridge. They do not hit my NIC team. They do not go out to my trunk. They go out the bridge. They come over here, and now they're talking to my physical box, going to my NFS server, and then to my NVMe SSD. This is a very, very, very fast way to be doing this. So actually, I was setting up the NIC teams and all that for bandwidth for a NAS box. This is actually extremely much more faster than any NAS box, limited because my switch is limited to just the 2 gigabits per second, or if I didn't have the team, it'd be 1 gigabits per second. Speed going around like this will probably give me up to 10 gigabits per second or even more. That's the research that is. But either way, I was told through my lessons learned that this is a good setup for doing a lab. So, all right, moving on. Just wanted to explain that little tidbit. So, end user comes across the team, hits the bridge. Now I'm into my KVM system. Now, there's a reason why I set up a cluster IP. So the cluster IP is software running on each VM. And the reason that there's a cluster IP is K3s advertises all all pods on all your nodes. So I can go to this IP address and get to any of my pods, no matter where they're running. I can go to this IP address and get to any of my pods, no matter where they're running. So I'm like, all right, well, if that's the design of this, then I should probably be utilizing a cluster IP. So got to come in through the cluster IP into my K3s instance, and yet again, 981 is the system controller. That's the full install of K3s. 982 is the agent node. And again, these are looped together because of what I just mentioned, that everything is advertising ports open. I took an Nmap and I did a scan of both of my nodes, and they were both advertising the exact same ports. So no matter where this pod's running, the ports are going to be open and available on either one of these nodes, hence the cluster IP. So now then, I kind of don't like draw. I wish I just had like I had a split arrow, but I don't have one, because it's kind of like this. Bam. So my system control and my agent node, you know, either one of those could be running either one of these pods, and you'll still be able to access it. And I have failover. So the cluster IP also gives me failover. If 981 goes down, then the cluster IP knows that and starts routing all traffic over to 982. Same thing happens in K3s. K3s notices, hey, as long as you don't lose your system controller, if say my agent node goes down, or you can have multiples, you can have 100 of them, I guess. So one of my agent nodes or worker nodes goes offline, the system controller knows that, and then will spin up the pods dynamically on another node. So I use my agent node is my primary, so everything runs over here, and that way if this goes down, everything will spin up on my system control. The system control can also be used to run pods, so just because it's system control doesn't mean that's the only job that it can do. So I got pods running here, and I have pods running over here. So now then, I got my two pods up and running. They can be accessed anywhere. They will also fail over due to the cluster IP, and because of the technology in K3s and the way it's designed to operate. And then the next step is my NFS shares, kind of like I told you earlier, kind of loops around through the bridge interface, but that's supposed to say PV. So these are my persistent volumes. So my persistent volumes, I have two different NFS shares, one for my Splunk and one for my SQL pod, and then I have an individual volume claim for each one of them. So that's pretty much it. I mean, it's quite layered and in depth, and I did not know what I was getting into when I first started this. But yeah, this is what I ended up with. I just kept going further and further and further, and my plan of attack is to buy another one of those little devices and expand on this environment. And you're also able to, of course, you don't only, this is a lab, so, you know, hey, what if the system controller goes down? Yes, everything dies. But you're allowed to have more than one system controller, and hence then you can put the system controllers into a cluster as well, or they're part of the cluster logic with K3s. So my next step is I'm going to buy another one of those little B-Link devices, spin up K3s on that, have another system controller. But at that point in time, the only problem I have is now my shared storage in this environment, even if I make it available to the other one across the network, if this environment goes down, then the shared storage wouldn't be available anymore. So I gotta set some priorities on where my pods are allowed to run, and so I can limit some of that, but yet again, I won't have true HA failover unless I go out and get a NAS device of some type or do some type of rsync or something. All right, let me go over one little step here. This will all be up on my website. So I am big on documenting everything because I don't have to try to learn it twice. So these are kind of like my logical steps going through here and what I had to do. On the right is my notes. When down under K3, this is just the order that I execute my YAML files for creating the different sections within K3s. And then down here, the top part's kind of the logical setup, and this is actually going through and actually doing it. There's two things that I want to mention. You're going to get some permissions issues when you first set it up. You're going to need to run these commands here, and this will copy the YAML, K3's YAML and config file over to your home. And that way you'll actually have the right permissions and access, and then you can actually add that to your profile and reload your profile. And this takes care of a lot of that. So that was very confusing at first for me because I am still coming new to Linux, so I didn't understand why I installed a program and didn't have access to the files that I needed, but I guess that's as per design. And also another thing, as per design, they don't know what your IP address is. So in the config file, see this where it says highlighted down here? Just got my 192 address. This is either going to be localhost or it's going to be a 127 address. So before you add your worker nodes into your cluster to the system controller and register them, you need to make sure you get into this config file and update this to advertise your system controller IP address. So this was yet again another big learning curve for me. The only other thing that was real big about this project outside the norm for me is I'd install a CSI NFS driver on the system controller only, and then K3s kind of takes it from there. So this whole section right there, I had to actually learn what this was, why do I need it, everything else, because I was trying to do it without it, and that didn't work very well, and I was banging my head against the wall for quite a long time. So I at least wanted to give this a mention, that this definitely needs to be installed if you're going to use my style of setup. For creating the NFS share, yeah, you can try to just set permissions, but the one big thing is the no root squash, because the K3 is gonna try to take over and do what it needs to do. And if you don't have this no root squash in here, it's not going to be able to access NFS the way it wants to, and it does do something with the permissions and so forth on the files. I saw different user accounts, like a UI, was a user ID, yeah, UID on my NFS shares after I set it up. After I spun up my pods. So making sure, what I did is I just limit them to what IP addresses on my network I want to allow them to have access to. 81 and 82, that's my two VMs. 100, that's the cluster IP for the two VMs, so I didn't know if it was going to maybe come across on the cluster IP. And then on 201, I just did that for some testing purposes. So I do have the NFS share wide open for all access, but yet again, this is just a lab, and I'm not running any, critical information in here, so I wasn't too worried about it. I just wanted to keep it simple, and then limit the NFS by IP address. Another big step, verify NFS access on all your nodes. So your nodes are actually going to be connecting out from the node once they spin up the pod on that node. So you want to make sure your nodes have access to your NFS share. So like this is my NFS server. So this would be the hypervisor host. Then right here, I just, get down, and this is where we're actually applying the YAML files and doing some checks afterwards. So I just put in the check commands so I didn't have to try to remember them all the time. So yet again, very, very new to all this. So these are a lot of the key points that I came across. Oh, just a little note. After you run your installer, you can run this command. That's going to give you your little token ID, which is like a 100-character key. You're going to use that key to actually register your worker nodes with a command, so you're definitely going to need to know about this if you want to add more nodes. So, all right, well, I've gone a lot farther and in depth than I thought. I'm going to make some more videos and actually go through and show you my environment, but I just wanted to make this one mainly to kind of go over, look at all the arrows now, to kind of go over my diagram that I made and make a little bit of sense of it in case somebody takes a look at this thing and goes, oh my gosh, what's going on here? All right, well, hey, thanks a lot for checking out my video and appreciate it. Bye-bye.